All right, so the power of a test is the probability of correctly rejecting the null. So power is a good thing. Okay, that is the probability of rejecting the null when it's false. So this is a truth table. If we offered a logic class, you'd make a lot of these truth tables. So this is your decision. I either reject the null or fail to reject the null. So what you decide at the end of doing your hypothesis test, your decision is either to reject the null or fail to reject the null. The truth, the reality, is one of two things. The truth is that either the null is true or the null is false. So if you reject the null when it's true, that is what we talked about last time, is a type 1 error. And the probability of that is alpha. Okay, if you reject the null when it's false, this is the right decision. Remember, it's good. Okay, this is the correct decision. And this is called the power of a test. Right here. Reject the null when it's false. Okay, failing to reject the null, if we decide to fail to reject the null when it's true, that is a correct decision as well. Okay, now the probability of the power of a test is 1 minus beta. Okay, down here, failing to reject the null when it's true is another correct decision. That is 1 minus alpha. And down here, if I fail to reject the null when it's false, that is the type 2 error. And that probability is beta. Okay, if the null is false, the probability of a type 2 error was beta. Therefore, the power of a test is 1 minus beta, which you will not be calculating the power of a test in AP Stats. You won't be calculating it, but you need to know it. Yes?
Is failing to reject the null when it's true, is that the power of a test also? Or is that just
No, that is just the correct decision. It is not the power of a test. The only thing that's the power of a test is correctly rejecting the null. All right, so power is good. You want more power, okay? So if the null hypothesis is really false, we would like to know, okay? The higher the power, the more chance we have of detecting the truth. For example, suppose that a new medication is better than the current medication. That's the truth. The new medication is better than a current medication. When the company does an experiment to test this claim, the power is the probability that they will reject the null hypothesis and conclude that the new drug is better. So let's take a look at a little example here. Just again detecting and naming the type 1 and type 2 error. So suppose that in 1990, in the 1990 census, 83% of Arizona adults had a high school diploma. The Department of Education believes this percentage has decreased. So they commissioned a survey to estimate the true proportion. Define the parameter of interest, state the hypotheses, and describe each kind of error in the context. And describe the power in context. Notice we're not finding the probability of power or 1 minus beta. We're just describing what power means. All right, so P, the parameter of interest, is the proportion of Arizona adults with diplomas. All right, and the null hypothesis would be that it hasn't changed, that P is still 0.83. The alternative hypothesis would be that, what do they think? Let's see. Less than. So P is less than So now, what is a type 1 error? So type 1 error is rejecting the null when it's true. So I reject that. So what do I decide?
It has gone down.
Okay, so the proportion has decreased, but in reality, what? It hasn't. But in reality, it has not decreased. It has not. The proportion, okay, I already stated up here, it's the proportion of Arizona adults with diplomas. So type 1 error would be that proportion is decreased, but in reality it has not. So what's a type 2 error?
You say it has not, it stayed the same, but really it didn't.
Okay, so we say that it stayed the same, but it did decrease. Now, the thing is, what I want you to understand here is if I hadn't stated this parameter of interest to start with, I would have to be talking about the proportion of Arizona adults with diplomas in each of these statements. But since I described what the proportion is up here, I don't have to do that. All right, so now power. What's power? Power is correctly rejecting the null. So you can describe the same way you did a type 1 and type 2 error. What did you decide? If you're going to reject the null. So what did I say? Okay, so I decide that the proportion of Arizona adults with diplomas has decreased, and in reality what? It has. If I correctly reject the null, I reject the null, and that's the correct decision. So I decide that the proportion of Arizona adults with diplomas has decreased, and it has. It has decreased. That is a good decision. Power is making a correct decision, correctly rejecting the null. Can you imagine an entire class of things of like similar to type 1 and type 2 error? It's called logic. It is, I think, a very needed class. Maybe not at the beginning of high school, but towards the end or in college. So, all right, so next page. What affects power? Okay, the power of a test will be higher if you increase the significance level alpha. Okay, so if you make alpha, let's look at the chain of events here. If you make alpha go up, what happens to beta? Beta goes down. Why? Inversely related, meaning one goes up, the other goes down. So if beta goes down, what happens to 1 minus beta? It goes up. The smaller beta is, the bigger 1 minus beta is, and that is power of a test. Okay, so if you increase the significance level, then you're going to make power go up. So again, you don't need to worry about how they're calculating these things, okay, because you will not have to calculate power. But these are just some examples. If the true proportion was 0.8 and alpha was 0.5, we took a sample of size 100, the power would be 1.1425. But if we increased alpha to 10%, the power would be 0.2234. That's a higher percent. A higher percent chance of correctly rejecting the null. So the other thing you can do is increase the sample size. I can ask more people. So, and that has an even bigger effect. Notice in changing the sample size from 100 to 1,000, you change the power from 14% to 70%. Okay? There is a larger effect size. In other words, there is a larger discrepancy between the null and its true value. If the true proportion was 0.8 and alpha is 0.5, and we took a sample of size 100, the power would only be the same as it has been in the last two examples. If the true proportion was 70, the power would be 89%. Okay, now what if the other thing that affects power is other sources of variability are minimized. So you make the design of the study be airtight, basically, okay? You have that full control over everything. You use blocking or stratified random samples. If you're dealing with averages or means, which is what we're going to be dealing with today, we're going to be doing a hypothesis test for X bar, mu. If there's less natural variability in the population, the power of the test will increase. And for proportions, the proportion is farther from 50%, it makes the standard deviation smaller. So all of these things will affect the power of a test. The main three that you need to know, if you increase alpha, increase n, and have a larger effect size. Okay, so, yes?
Could you go over effect sizes?
We don't need to spend that much time on it. Okay, you need to know what it is a little bit, but we don't spend a bunch of time on it. Okay, it's not like you're calculating that. Okay, if it needs to be brought up again, we'll go a little bit deeper, but right now it doesn't. So and then just there's a larger effect size. All right, those are the main three you need to know. Which of these can you control? The first two. You can control 1 and 2 because you can pick alpha and you can usually pick n, okay? And 4 somewhat. Okay, effect size really isn't something you control because that has to do with the true proportion. All right, are there any disadvantages to increasing the power? Yes. In number 1, if you increase alpha, the disadvantage is you increase the probability of what? Alpha is the probability of what type of error? Type 1. So if you make alpha bigger, don't you increase the probability of a type 1 error?
Oh, yeah.
Yeah. So you increase the probability of a type 1 error. And if you do 2, what is it always, if you increase n?
It's harder to do.
Expensive.
Costs money, costs more money, and takes time. Money and time. Those are always problems, right? And then 4, if you do all of these, if you do, especially do blocking or stratified sampling, your experiment or your sample is more complicated. So you have a more complicated design. All right, so that's everything on power. The other topic we're going to cover today is a hypothesis test for a mean.